Oh, wait,
No, no.
I can tell you a story today. How's this?
Oh,
So I'm going to have to wait and have Sandy retell this story. But at dinner, when I was in Vancouver at the Fully Charged thing, he
his
told,
shirt came off again. Oh,
no. He
no.
told why he has a scar on his arm, on his chest, though. Because
Oh,
I'd seen that when he took his shirt off. No, the shirt did not come off, but the story behind it came out. He used to play semi-professional soccer when he was in his 20s, which is crazy. I did not know that. So anyway, but he was a defensive man. And he was playing, I can't remember the team that he said he was playing, but anyway, it was in the United States, and they were playing, and he scored a goal. Sandy tells us much better than me, but he scored a goal as a defensive end, which is like my first goal and my last goal in semi-pro soccer. And so the defender on the other side, he, started saying a few words to the guy, and some choice words of like, aha, I bet that you'll never see that one again because I scored. Anyway, he said that the guy got really mad, and he said not 5 minutes later, the exact same thing happened, and he had the ball again, and he was driving for the goal, and he was like, damn, I'm going to score 2 goals in one game. Well, the next thing he knew, this dude had taken his arm and almost ripped it out of its socket, almost completely off.
oh,
Yeah. So he ended up in the hospital. They told him, this all came out of Ellie's story, because I told about the story with the titanium, and that they said if she broke her leg again, it would have to come off. And he basically said that they didn't know if they'd be able to save his arm. They thought they might have to amputate it. It was so badly ripped off. Yeah. So
wow. Not just
yeah,
a
this is
normal
beyond just
dislocation.
normal dislocation. He said it was like basically hanging.
I mean, wait, was this soccer or rugby? I'm a bit
so
confused
well, okay,
here.
but the story gets
I hope there was a red card involved.
Yeah, so he said that they knocked him out for like 2 weeks in order for him to not move, so that he would like recover. And he talked to he was dating a girl at the time, and the girl's dad was like really a big fan of his, and had looked into the story after this had all happened, because Sandy was like, I was out, I had no idea what was going on. He said it turned out they couldn't find this guy. They were looking in the immigration, they were looking at his birth certificate, they couldn't find anything valid on the guy. They finally went to Interpol and found out that the guy was guilty of murder in Turkey and had escaped, and was like living under an assumed name in the United States. So he had his arm almost ripped off by a Turkish murderer in a semi-professional soccer game. Not many people know that one. Hey, y'all, it's Dr. Know-It-All. Guess who I am with again? It is Dr. Scott Walter, and we have Walter Isaacson. Speaking of Walter, Scott Walter Isaacson, we've just mashed this together. He's got a chapter, I believe it's chapter 77 in his book, and I did have
79, but mainly 77.
Oh, 70. Yeah. Okay, yeah. So
There's
I did cheat.
chapters.
I went forward in time. I'm still reading it from the back to the front, but I went forward.
Me too. I went straight to those chapters.
Yeah, exactly. So we're terrible. I usually don't read books like that. But anyway, welcome, Scott. We are going to talk about Optimus and some little nuggets that we found out from Isaacson's book. So welcome, as always.
Yeah, thank you. Thank you. And I was procrastinating on this whole thing because I was trying to leave something for my family to be able to give me for either Christmas or birthday. And then hearing like everyone else saying, oh, have you read this? I found this. So last night I went ahead and ordered, and I got the Kindle version and went right around there. And wouldn't you know it, just a second ago, I heard their doorbell ring.
Oh, wow.
Okay.
That is good timing. Check that out.
It is. And sorry, Randy Kirk and Lars and John. Your book is moving to the side here. We've
been shifted over. That's okay.
We've been shifted. Yeah.
We will give place to Walter Isaacson. He deserves a little bit of credit.
So the book's right there. I'll probably crack it over because there's no way I can like really read like the whole thing from cover to cover in Kindle. But I did have a chance to review the 2 Optimus chapters that are in there, which are 77 and 79.
Right.
And it's interesting. So how do we want to go about it? I've marked it up.
Well, let's start with the picture that starts chapter 77, which is Optimus hand, Optican hand, or whatever.
Yes.
Yeah. So there you go. I think you've got it queued up, so you're ready to roll.
I don't see it. Did I grab the image? Oh wait, maybe what I can do is I can go straight to, because I do have.
I may be able to find it myself.
Yeah, the thing is, I found that Kindle was really pretty bad at being able to. Well, there's probably a way to do it. I just didn't know how to do it.
I pretty much have to do screen grabs. That's the only way I can.
Yeah, that was the only. So I did the screen grabs, in order to be able to do the highlighting. And okay, now I've got
Right.
the screen grab here.
So here we go. So we've got a couple of images real quick. They're actually part of one image, but I blew them up so that we would be able to see both of them. So we'll start with this guy. So, you know, B build hand, not exact. I guess that would be Bumblebee before Bumble C. I'm not sure. Anyway,
I don't know. Maybe I don't know if,
yeah.
if you know that. Yeah, maybe it's just they had an A and a B out there somewhere.
Yeah.
Sure.
So obviously they say part reduction, improved assembly time, controller packaging, sensor packaging, external glove, which is not there. We have not seen that yet, which might look like an actual glove, which is intrusion protection. So waterproof, dust.
We may have seen it actually. I think in some of the videos that they had there, they may have had something on there. Yep.
Right. And so cladding and gripping surfaces. And then real quick, we can turn to this guy and you see, where does it say like female finger? Yeah, female 50th percentile.
10% percentile hand. Yep.
Fingers. Yeah.
Yep.
So anyway, identical finger lengths, which we had already discovered. Good job, Scott.
Yep.
And identical metal tendons. So all the parts are the same. Identical actuators and worm drives, except for the thumb.
Yes.
So
except for the,
all of these guys here are the same. All of these fingers are the same length. Obviously, they only have 2 joints each, as we've seen. So there's one joint, one joint there, one joint there. And the thumb has, I can't quite tell. That looks like 2 motors there that are driving.
Yeah, there's 2 motors. There's 2 motors. So, you know, normally our fingers can close like this, right? And so the thumb can do that and then also close. So it's to get the 2 degrees of freedom you have in the thumb.
Right.
And your fingers can do this, but it's not designed to do that. It's only designed to clench.
Yeah.
So again, you can't play the piano because you won't be able to span your fingers out or anything like that. It just comes down one particular way.
Exactly.
And the other trick that's in there is that you notice that the fingers are a little bit offset along the palm to give the illusion of, you know, this kind of top of the fingers. So, and that's how they were able to make the pinky the same length, is that they just offset it down to be able to do it.
Yeah. Which actually, if you look at our human hands, that it does it a little bit there too.
There's a little bit of an arch there.
Yeah.
So, and it turns out they discovered that they needed to have 5 fingers.
Yes.
Instead of 4. They were thinking that, and they realized, and because remember all our speculation, we saw, you know, the image.
Yeah, the love image
is first on here. It's like, we see a thumb and like an index finger, maybe a second finger behind it. Must be only 3 fingers because that's all you need.
Right.
You know, the idea is that, and you see that in science fiction all the time. It's like, you know, the aliens always have just 3 fingers.
Yeah,
that's all you need. And so it would be really hard for, well, maybe there's a 4th one. So until we saw the hand, we really had no idea which way they're going. And you can see they were.
You can see if you stand up, you can see the robot love. I think that image is the original image.
That's the original image that was very difficult. Yeah, very difficult.
Did I?
Well, actually, it's probably hard to see.
Okay, now wait a second.
Like,
watch this.
Right now.
If I say the word love. Oh, I don't know. It just did all these hearts that popped up. So I don't know.
Oh, yeah.
I don't know what in the world. Yeah. The Zoom thing is crazy. So anyway, but yes, so we couldn't tell originally, but of course they have 4 fingers. Now it was interesting that they said that there was a creepiness factor if they didn't have 4 fingers.
Yeah. And it might be kind of interesting to go through the whole timeline and everything else they had on there.
Okay. Yeah. So anyway, I think we didn't discover, one thing that I did discover from this was just that we were talking about a female sized hand. If they were
which is, you know, usually when you do like ergonomic studies or you try designing a certain station, you're doing it to like a 50th percentile.
Right.
And you sometimes have to look at like a 50th percentile male and female to get, you know, what might be kind of the big and the small size to make sure everything sort of fits in there.
Right.
So I'm not sure why it was, you know, why they didn't do it like just 50th percentile in general of the population.
Right. I think there was something in that chapter that Elon
wanted feminine hands or fingers or something like that. And it's like, tapering. It doesn't matter tapering, you know, it's
right.
And, you know, maybe that's something kind of long-term, but if the idea is just to work in the factory, you just want something which is, you know, the best ergonomic fit. And a lot of times,
I think what I would have
tools and workstations.
And I may have been jumping to conclusions, but I was perhaps jumping to the conclusion that the whole idea of this robot was to make it as unthreatening as possible. So if you make the hand smaller, then the hand is less threatening than it would be if it was like a big meaty hand like mine.
Yeah,
Like
yeah.
everything.
I think that was part of the idea.
Right.
Absolutely.
Right.
Absolutely. Now I can try to share my screen here
Okay.
with what's actually in the chapter.
Sure.
And let's see, let's get zoom back up here and make sure I can go ahead and share. Let's see. So share the screen again. Go ahead and do this and share. So there we go.
Yep.
All right. So we can see that. So the first thing that's interesting is that,
Yeah.
it starts in August 2021.
Yep.
Right after the announcement. And then this is what kind of struck me a bit hard. A few days later,
Right.
Franz is the one who is suddenly told to design this thing.
Right.
And to me, it's like, wait a minute, there's going to be a chapter before this, because there was 3 PowerPoint slides up there. And those 3 PowerPoints were not just something that was made up the night before. There was some thought that went into it. And I'd like to know where that thought process came from and everything else. So that's the first thing that struck me was going on. Because you remember, the very first idea, the first time the idea of Tesla building a humanoid robot was about 9 months before, when James Dalma brought it up in a conversation with Dave Lee. And he didn't say they would, he said they could. He wasn't predicting that they would do it. He just said that they had all the pieces to put it together. The question is that when suddenly Tesla, took notice and said, maybe we can, or had they already been doing it? Because at some point, we made a lot of hay of those 3 PowerPoints, especially one of them. Yes. So there was some thought that went into it, and well, who was thinking about it? And so suddenly the day after the thing, it's like, oh, I guess we're going to start building this thing. Well, let's get a team together. It's like, you don't already have a team? And then I didn't think if Franz was being the person to lead that team, because wait a minute, he designs cars. He doesn't design robots.
Yeah.
So to me, this whole thing seemed a bit funny. And I'd like to know what was going on before, because I'd like to know where those 3 PowerPoints came from. And if there was no meetings or design or anything like that, then Elon took it out of his little cache of alien artifacts.
Right. Well, the thing that's even more bizarre about that is, forget about the PowerPoint slides, because you could whip those up relatively quickly, but the costume would take a period of time to create.
Yeah. Someone had to create the costume.
Right. So they had to have.
And remember, they already had a 3D model. That was the other thing that was up on the stage.
That's right.
So they had the intro video, and they actually brought out the 3D model and everything. So there was already a bunch of stuff of the idea of what kind of the pathfinder or what we want to do. But what was more important is in that model is that we could sort of see inside. There was like an X-ray that was going on. And that, I don't think that was just a designer taking liberties of throwing some things in here. They look cool. Because when we started to examine them really closely, they were thought through. I could see the mechanisms in there and remember how we overlaid them, and they seem to match pretty close to what was Bumblebee. Now, obviously, in a later generation, they changed a few things, and which we are going to see as they kind of go along here in the discussion. So the first thing that's going on there, and then of course, Elon says, with no wheels, and he doesn't want it to be 4-legged. He wanted it to be 2-legged. Now, a lot of people have brought up, and I made a tweet that everyone thought was kind of a really bad dad joke, is like, why do humanoid robots have feet instead of wheels? And it's because they have a smaller footprint. And it may seem like a joke, but that's actually the reason, because if you think of like a Segway, think of the footprint of a Segway for you to stand on it. That's basically what a humanoid robot would need to have to be able to go around, and for stability and everything else. And it just doesn't work in a lot of human spaces. You want something with literally a small footprint to be able to get around and do it.
I was at the Fully Charged Live thing again, and there was somebody on a Segway as like a security person, and it was always problematic because they were trying to get through areas that were too small,
too thin. You just can't get in. You're trying to get into a tight workspace. You're not trying to expand literally the overall footprint of your factory floor. You're always trying to keep it smaller. And when you have to make accommodations for wider vehicles like that, it becomes a problem. Yeah. So, again,
I do have to say, okay, so remember that we are talking about Walter Isaacson's book here. And so it is a human being writing this book. It seems almost impossible to believe that some of these decisions were made after the robot appeared on stage.
Because when I was looking, remember, we even talked about like the angle of how the arms were attached together. That first they were 30, and I thought that was a really good decision. And later on, they put it flat out. So it was like a decision to change that. but someone who knew what they were doing came up with that design. And I would think whoever that person was would be the person leading it and not Franz. And so to me, it was like, oh, well, I guess they haven't been coming out with a whole lot of vehicles to keep Franz busy. I mean, it's not like he's designing. Well, I mean, obviously he is. They are looking at these things, but you think about it, it's like, oh, Jim's got like 17 vehicles or something like that. So, you know, that's what a Franz should be doing. He's like every month coming out with some new design for this thing. And so I think he's like, how does he keep himself busy? Oh, put him on the robot project.
Right.
But again, the emphasis to accommodate the way humans do things, you know, it has to be able to work on all those things. And they start out with like, you know, 10 engineers. It's like, wow, okay. And they just sat, and this is like what? Oh, this is just a 2-hour meeting amongst 10 engineers.
Yeah.
So maybe that's the only one that Walter got a chance to sit in on. And, you know, here's like one of the first, you know, they wanted to add improvements to what humans can do. And, you know, first they're in this design meeting, it's rather interesting, but they want to make this thing superhuman.
Exactly. Yeah.
And then the idea of like picking up a power drill. And I was like, well, you don't really need a pinky for that. You know, we'll just go with 4 fingers. You know, since this pinky seemed unnecessary. And they said it looks creepy. Okay.
Exactly.
And now this is, and then of course they started talking about all sorts of other, you know, because this here I think is funny. So I couldn't read this correctly the first time. It was elongate the pinky as opposed to elongate.
Elongate.
You know?
Yes.
It's like, all right, we got the elongate pinky. So pinky gate. So you know,
they started calling it that, the elongate, for like
right. And again, the simplification that 2 joints rather than 3 in your fingers. So your fingers can do this. And I'm assuming I'm getting my camera on up there. And the thing is, when your fingers are straight out, you have that, and that second joint, or the joint at the very end, just kind of bends a little bit and then never does anything. And so what they did is like they pre-bent it and just kept it there, and then changed the dimensions to these things a little bit. So you really have the joint down here and the joint over. Good design decision for that reason. And they made some changes to the palm to make it a little bit easier to grab the power tools. But
and the other design decision, the pinky's not only stronger, but it's identical to the other fingers, which means you only have to build 1 finger and just replicate it 8 times per robot.
Yes. So, that comes up again and again and again. So they were looking at some ways to be able to prove it, and, you know, one to get more power and all these other things. And when you come back to that creepiness factor, that's very important. And a story with my own company is we got one guy in our company. I was talking to him, you know, about modeling human arms and stuff like that, and the fact that, you know, unlike an industrial robot where they can bend the elbow, which we call like the second configuration, the human arm doesn't do that. So you can make an assumption like that. And I didn't know it, but he was actually double jointed in his elbow. And he then kind of went up and did this thing with his elbow. And then one of my colleagues promptly went over to a wastebasket and started retching because it was just so unexpected. Nobody in the office knew that. And I mean, it wasn't a little bit. I mean, you can do it a lot. It's just like, if you're not ready for it, suddenly you're just like, ooh, that just doesn't look right. So what you need to do is you don't want that creepy factor for sure.
Right.
And they were trying to come out, you know, again, you know, all these things that, you know, where people would freak out, you know, with a hand going all the way back to be able to touch it and stuff like that. You just don't want to do it. So that's a rather interesting thing in the discussions, you know. But the other thing I kind of get out of it is like, I'm looking, it's like, there's not one biomechanicist. I mean, they should have had Gary Schneider in there. Because they knew nothing about, you know, throughout this whole thing. They keep on going, wow, it's really remarkable what the human body could do. They're discovering it, and they're sitting there flapping their hands and figuring out, well, how much can the wrist move this way? And that was like, you guys didn't know that already going in. So this is like a ragtag motley crew of people that came together to design this thing. I mean, that's the conclusion. I'm like, oh my God, how did they pull this off? Because it doesn't seem to me like they knew what they're doing. And then the more I think about it, it's like, you know what? That was probably the wisest choice. Probably the worst thing was like to pull in all these like super industry experts, people who have been working on it for like years and years. And they would come in and they would be like, you know, fighting against each other. What's going on? The egos would kind of get in there. And someone would say, no, it's going to be done this way. This is absolutely, you guys know absolutely nothing. And it's like, that was their superpower. They knew absolutely nothing. It was like, you know, first principles, blank sheet.
You go back to the early days of that's the chapters I'm in right now, is the early days of Tesla. And part of their superpowers were that they knew nothing. They
know nothing, and yet they pull it off. So I'm reading this thing, and the more I'm reading it, I'm having like less and less confidence in Optimus. Like, these guys don't know what they're doing. I could have been in those meetings. I would have been the smartest guy in the room. I mean, whereas I was like, if I had been there, I would have felt like a total dummy and couldn't have contributed anything. So the wrestling with these things are rather interesting. And again, human bodies, Musk and his engineers discovered, are amazing. Whoa. After you say you're going to design a humanoid robot, you just discovered that?
Yeah, exactly.
And then, and so they discovered, one of them is like, how the fingers can apply pressure. Oh my God. And they can feel pressure too. Shit. What are we going to do? It's like, okay, some really great revelations here. So, and then, and again, this is what James and I have been saying is what they're going to do.
Yes.
We could look at current in the actuator of the finger joint, which will correlate to the pressure being applied at the tip, what engineers suggested. And they're all like, nah, it's like capacitors, touch, all this other stuff, barometric pressures. Are you kidding? And finally, it came down to, and again, this is Hans.
Right.
This is why Hans is important. He asked the question, what are the differences in cost? Oops.
Right.
They decided the measuring the pressure using current flow in the actuator of the joint would be most effective because it wouldn't add parts.
Right.
That's the whole thing. Everything comes down to part count.
Well,
and this is what I've been hammering all along. This is what I've been listening to them. And this is what I'm saying. Their decisions are being made on simplicity, manufacturability, and part counts. That's why all the fingers are identical.
Right. Well, that's why Optimus looks like what it looks like. But I think so going back to the beginning of this chapter, my reading between the lines with Walter Isaacson here is not that Franz was designing the look of the robot. They brought him in to design how to build it and how to do it right. So that would be my guess. And that's what started after AI Day. Obviously they had built a prototype, just something that like it looks like this, and they had a basic idea because we had that PowerPoint slide. But I think because when you think about a car designer, their job is not just designing the car. It's like, well, how the hell do you make it now? It looks beautiful. How the hell do you make it?
And Lars too. You pull them both in a room. But I think there is going to be a great book just about Optimus because the origin of this goes way, way back. I don't think it's necessarily that James Dama mentions it and then so everybody goes, oh, let's 3D print out something and get this ready for that. So, some thought went into it. And I think some thought went into it before. And I think I've sort of mentioned that, my theory is that, Elon read all those books when he was a kid from Asimov about that. Right. And that most of us, when we read it, it's like, oh, cool. In the future, there's going to be humanoid robots. And Elon was like, oh, cool. I'm going to like invent these in the future. I'm going to be the one to do this. And it was probably one of those many projects in the back of his head that he was waiting for when the tech would come together and the need. And then when you had production hell, with a Model 3 and he's sitting on the floor figuring out why nothing is working, he is probably saying, it's time, and he probably just started, maybe discussing with, a few people here and there, not too seriously, but kind of getting the idea till finally they were able to crystallize something to create those PowerPoints. He probably gets someone's like, look, just, whip up something. What do you think a human would look like and do it? But we don't know who that person is. And I'd really like to know who that person is because it's not identified. Yes. Someone put something in there. Yeah. Right. And then, here's Elon being practical and throwing all these things out. First, the number of actuators to provide the given hands with enough dexterity and how much is going to be there. This idea of swapping out arms is like, no, it's like, it's no, that's not how it's going to be. We see it in sci-fi. Oh, that's really cool that, like you put a new hand on something like that. No, we do that with industrial robots on the shop floor, but humans pick up a different tool. That's called swapping out tools, not swapping out hands.
And again, just to reiterate that thing we've talked about a lot, and that is that we have all these tools already. They exist. So instead of making a new tool to put on the end of its arm, just use a drill that everybody else uses. And it already exists and you've got lots of them.
Exactly. Which is why the hand had to have the pinky and all these other kind of shapes. And Hans was like very concerned to make sure, what would you need to be able to pick that up to make sure it would work. And the other thing is that even though Elon is like joining these meetings remotely and all these other things, he's got a lot of valuable input in that he knows where to draw the line and everything to say, no, it's got to be this, it's got to be that. Yeah. And then, again, down to the screen, what the face is going to be is like an obsession about it. And it's just like, it doesn't need to be a touch screen for once. Don't obsess on that. And it's
Yeah.
not necessary for the first iteration of Optimus. So again, let's get something out there that's working, and we'll talk about these embellishments later on. So keeping
Right.
everyone focused on what's important and not trying to do anything else. And then, later on, they're like, oh, some time looks like it's wasted with some CGI to keep Elon happy of like what it's going to look like of
Right.
a colony of working on Mars. It's like, guys, that's not focus. Get back into focus. And Hans tries to literally bring them back to Earth.
Franz, by the way, we're talking to Hans next.
Yeah, Franz, yeah, yes, Hans, yeah. So Franz is getting, and then but we should do one to show the robots working in one of our factories, maybe performing the repetitive tasks that no one wants to do. And the reason why I underline that is, they've mentioned boring repetitive tasks, and I think anyone that is running a large corporation where you have to hire in workers are always finding that there are these jobs that are very important that nobody wants to do. You cannot keep them there. They don't show up for work, they quit, and you're always finding someone else to do something like that. So in many cases, they're just like, that's the main reason they want Optimus, is that they're just jobs in the factory that no one wants to do. And they're harder and harder to find that because fewer and fewer people want those jobs. They want something a little bit nicer. So that's a very interesting thing and glimpse into their thought process of what's going on. The other thing that I kind of wonder here is like, the discussion of the butt plug.
I seem to recall us talking about this too.
Yeah, but the thing is like, after a few laughs, he rejected the idea of having a butt plug. As far as I can tell from the model, that is probably about where the plug-in port is. And we haven't seen evidence anywhere else. The biggest evidence is probably there is a butt plug. Could be wrong, and there's something else that's kind of hidden. But when we look at the models that are out there, so I think they may have, this was early on. And then, when the next one came out, they, went ahead and did that. And now then, let's see the next slide here.
Again, I love that Asimov's rules of robotics comes in. Isaac Asimov would be happy.
This is very important. And at some point, this is going to be worth a video itself when we start talking about, security of robotaxis and robots and everything else. And again, this focus of this concern of deadly robot armies, which is why I've said they're going to lease them, and they're going to be very careful who they sell them to and everything else, because they do not want this technology to kind of get into the wrong hands and, to be able to disable them and everything else. So that is foremost in their minds, is that they are not put to unsavory purposes.
Well, just before that, it also says, though, ruling out the use of electronic signals that could be hacked. So also, as with the vehicle, I believe when the car is in motion, it cannot be, it's basically a walled garden at that point. Nothing can get in. And so Optimus, it's the same thing. Just when it's plugged in or asleep, then it can be upgraded, but not when it's actually being active. So
yeah. Now, the other thing that becomes kind of important is that, the idea is that they really wanted to focus on cost and scalability very early on. Because Elon, wants to be able to produce millions of them. And so they had to focus on that. And, so again, they looked at the wrist. So you remember, we had a lot of discussion of what was going on with the wrist. And the original Optimus, had only 6 degrees of freedom on the arm. And, I had to look, it's like, okay, the 6 axes were the thing. I could see there was 3 up here, which meant there was 1 here in the elbow. Which meant you only had 2 down here. So I said, well, you're doing that. And the reason why you're doing that is that this yawing back and forth is not so important. You can actually accomplish the same thing with the redundancy that you have in the elbow up here at the shoulder. It's actually the shoulder joint, but it's what they call a kind of a redundancy on the elbow. So you can kind of get away and not need that. And you can believe that that's going to be the way to go. So to properly do a human arm, you need to have 7 axes, even though you think you should only be able to get away with 6. And the way Industrial Robot does it is they put 2 here, not 3, then 1, and then 3 are here at the wrist. But the way they accomplish the 3 axes of movement out there is with these big bulky mechanisms. And if you look at a lot of the humanoid robots that are coming out there, they're putting these big actuators here and here to be able to accomplish that and do it in a serial fashion that is not really elegant and is bulky. And it's because that's the only way they know how to put those rotary actuators in there. So they're obviously wrestling with this problem and then trying to come up with a solution. And Bumblebee was only 6 axes, 6 degrees of freedom. It could only do this motion. And it had I think pretty much agree at some point, when they're going over that, Elon said, this is a shitty design,
Right. Exactly.
and he wanted something, because what they were doing is, there's also movement in the elbow. So when we look at the original Bumblebee, and somewhere I've got a PowerPoint to show that, if we want to pop that one up.
Yeah.
And what
also,
it does,
while you're finding that, I think the cost is really interesting, because this starts to give us some concept of costing, because, if we're looking at least in the early iterations, that the wrist with 3 degrees of freedom, just that part was going to be $1,100.
Yes.
You can start to project out the cost of the whole robot from that, and it's more than you'd think.
Yes. So here it is. So what they have is they have a rotary actuator back here,
right?
Because they didn't want to stuff it in there, so they have it way back here.
Yeah,
and then you have this linkage mechanism which comes in to be able to do that, and the whole thing is like, you basically are taking a rotary motion to try to turn it into a linear motion to go back to create this rotary motion. And also, I could have mentioned, well, it's kind of big and bulky, and it only performs at 1 degree this way. You have nothing like this.
Exactly.
And so eventually, he says, use the liftgate mechanism.
Right.
It's
which is really clever. It's like, hey, we already got one of these. Let's do that.
The liftgate mechanism is basically an actuator that is a linear actuator. Just kind of sits it out, comes on back in there, and it says, which we know how to make cheaply. Okay.
Exactly.
So again, it's like, we know how to make these things. So then the idea is that, well, wait a minute, we're using kind of this push rod to get the pitching motion. What if we use 2 push rods, and if we push them together, we get this, and if we go that way, we can get a little bit of that yaw. And the thing about your hand is that you don't have that much yaw. That mechanism they came up with, you have this eye bolt that's in there that has a dominant axis where you can get a lot of rotation this way. I mean, it's almost as if it's not there. And then it has this other thing that just to kind of take up the slop like that. So you can't go plus or minus 90 degrees with it, but neither can the human hand. So there's no point. So it's like, it's really good. And what it means is, like, those 2 actuators, because they're parallel, you can combine them together to give extreme power in the pitch.
Right.
And if you really wanted extreme power this way, everyone that's coming up with the serial approach of like, well, we're going to have a rotary actuator here, which is going to this movement, and then right underneath it, we'll have the other one that does that. And you know what happens is that you're carrying a lot of that load to be able to make it just do this. So some of your torque is going into carrying that payload there that doesn't need to be there, and it's much weaker. You cannot combine these 2 in the pitch direction. The Teslabot can. You can take those 2 actuators, and those linear actuators are darn strong. I mean, they really are. And so what that means is, like, if you grip something and you got to hold something that's really heavy, it's going to be able to apply the torque that's there. So so basically, this motley crew that doesn't know what the hell they're doing as far as designing a humanoid robot has figured it out. Okay. That's really the point that I want to get down to. And like these numbers,
let's not forget, there's also the added advantage, which is that the wrist is thin, like in a human being.
Yes, it's
because you don't have these, which makes it much easier.
It's gotta be.
Yeah.
Yes.
It's got to fit where a human wrist would fit, and that means it's got to be thin.
And the other ones, the wrists are just getting so big and bulky, or because they can't really put everything right here, they end up having like the yaw back here. Right. So the wrist is actually like bending back there. Talk about something creepy. So, and that means you can't get in and get access to certain things. So that's gonna be a problem. Now, these spreadsheet numbers they put in there, how much the wrist is gonna go, those are early estimates. I think in the end, because of this design they came up with, it probably doesn't cost them any more for that extra degree of freedom. It really doesn't.
Right.
Except, the cost might be like however much the extra
you can start
actuator
to put
is.
some numbers on it. You could say, well, that means each wrist, after you cost it down and stuff, maybe $500 a wrist. So then you can start to like add up the cost of the bot,
The only thing I would look at is say, okay, the original wrist design, they had like 1 motor in there and the connecting rod and everything else is going to be in there, and all the attachment points are going to be on it. Now you're going to something a bit more of these little spherical joint connecting rods. You're going to have 2 in that. Oh, now, God, we're going to have 2 motors here now.
Right.
So are you telling me the difference in the cost between the 2 motors and that is $400? That, I mean, you'd almost say that, oh my God, that means their actuators are $400. If their actuators are $400, oh boy, my estimates are way off, on how much
especially the small ones, especially the small ones.
Yes. So I don't think the actuator costs that much. I think in the end, once they designed it out, there's so few parts there that I have a feeling it's, you know, it's not like going from this to that is a $400 upcharge. No way.
Right.
Absolutely no way. Yeah.
Yeah.
And you know, then of course walking. You know, that, you know, and you know them, and it's really interesting that Elon is seeing a lot of this through the eyes of X, of like, you know, watching a child walking and realizing that, yeah, they're pretty bad at it at first, and they get a little bit better, and then the idea that you're flat-footed, then you start having the toe off and you start throwing the arms in there, and it takes a while to get there. And then again, of course, you know, the team is discovering all this stuff. They get the first steps in Eureka, and then they're actually able to get Optimus to walk
and carry a box, which is
carry a box, which is important. Yeah. So walking, carrying a box, because suddenly that throws off your center of balance.
Right.
But they were having problems coordinating the arms and legs. And again, this comes down to why you have a neural net. You do not want to do that heuristically. Do not attempt to coordinate the arms and legs or anything like that with the heuristic. You will fail.
Well, and look at the very next thing here. Because the head had to swivel for the robot to see its surroundings. It's like, why didn't they think?
Just imagine, I'm sitting there with a box and I turn my head. Whoa, lose my balance. You know, but you just moved your head for crying out loud.
These were the automobile engineers. Why didn't they think about just putting surround cameras on this? And, you know,
exactly.
It seemed like the obvious solution, but obviously that was not.
It was in the original, you know, AI Day One PowerPoint. You know, they had cameras. They even had cameras in the chest. And again. But the original one did have, you know, movement of the head, even though it had all those cameras. And that was like the head scratchers. Like, well, wait a minute. If it's got more eyes than a fly, then why do you need to, you know, have the head move around? It didn't make any sense. So again, it seems like they were thinking of putting in there, and then finally, you know, Elon says, get it out of there. We don't need it. Now, the only reason you might need it is that you may have the dexterity that's required in some cases, like getting into a car, if you want to do that. That's why I say it won't be a valet, because without that head going down, there's no way it's getting in there. Even the Cybertruck might be a stretch, you know, but Model 3, no way. It's able to get in there, and without more flex in his torso as well. So between those two, there's no way you're gonna do it. And then it get interesting that, you know, the typical Elon thing, oh, let's bring in some toys and look at that and get inspiration, you know, which is where the casting came from, you know. So again, you know, these great ideas. So he believed that the toys offered, you know, really great lessons. Now, this is a great book. Unfortunately, every chapter is too short.
It is. I want him to like triple the length of every chapter.
Oh, absolutely. I wanted the chapter before this, and I wanted something else. And every chapter is like this cliffhanger. And unfortunately, it remains that way, because the next chapter is a completely different topic and you never kind of get back to it. So so that's kind of what's there. And then there is the actual AI Day 2. So if we want to kind of take that one on here, are you ready to go?
Do you want to do it in a real quick? I know we both have limited time because we are doing a live stream with Hans in just a few minutes. So
in a few minutes,
let's do a speed run. We can come back
to reading on here.
Like
now, I think we can, because
this is like
this is very short. This is very short. And the thing, of course, is that, you know, Milan Kovac, who I think ended up really becoming, you know, the head engineer of the project, you know, after you know, whatever Hans's role was, you know, he already like was suffering from PTSD from not doing such a, I guess, great job at having too boring a presentation for AI Day 1, which is saying a lot, man. Oh, geez. There was some pretty dry stuff. So, man, I'm impressed, Milan. I want to see that thing, okay? But you know, the most important thing is while it was, you know, obviously very rough on him, you know, kudos to him, but I decided that the mission was too important. Damn it, we need more people like that. Okay. So I mean, that is just something else that, you know, and you see that with some of the others that also had like harrowing experiences that kind of left and came back and everything else. And they're like, yes, it's frantic, it's crazy, but I will go crazy not doing this stuff. There's a sense of purpose that they get, that you kind of come in here to a lot of them. That they pointed out, which I think, so, you know, of course, the day of it, the robot, and this is kind of important, is that suddenly it's like, oh my God, he walks out in the shop floor, which is concrete. The stage is slippery. And the robot has to adjust its stride and everything. And
Right.
Elon's not happy with that, and he starts doing the silly walks to annoy everyone. And the engineers had to figure out how to get that thing to actually take bigger steps. So
Right.
again, walking is not easy because every
No.
surface ends up becoming a huge challenge.
But this is also, there's another little nugget here, which is that they are heuristically programming this here. This is
Yes.
not something where it is learning from watching other people walk
Yes.
like videos. It's actually being programmed into it. So interesting note here. I'm sure
Yes.
that that's something that will go away over time.
Oh yeah, and it's basically gone away because now they're doing the end to end. So
Right.
remember, this thing here is like, we're going to look back at them and say, this is an amazing team of guys,
Yeah.
and gals. Okay. But when we look at what they knew coming in, it was just like, yeah, these would not have been the people I would have picked.
Right.
It's like, they may have been like a really good mechanical engineer, known this, but I don't think, they're completely out of their league. They are definitely not the ones to design this. And it turns out maybe those are the people to design these things.
Exactly.
These are the people that change the world because they come in with a complete clean slate, a complete new look at everything else. They pulled a miracle off to get this thing going. So when you're looking behind the door, it's amazing. And now I think they are getting to the point that they are really picking up that head of steam and they're starting to move ahead. All the pieces are starting to come together. So at first it was enough to be a super impressive demo, but now it looks like it really is coming together, which is why I'm a little bit off on my time frames of, how many they would have sort of ready by the end of the year.
Yes.
Because, they have to build that foundation, as James always talks about. And then once that foundation happens, suddenly, boom, the skyscraper goes up.
Right. Right.
And again, AI Day, does this sound like what would have happened to AI Day? Dozens of engineers were scurrying around with worried looks.
Oh, hell yeah.
Oh, yeah. Oh, yeah. And the demo effect, like a connection came loose. Oh, who would have thought of that? And then poor Milan, I mean, he's just like, oh my God, I can't believe it's happening again. So it's like, I really feel for the guy. And again, examples of one guy, I was so bored, a guy who left, I called my boss and begged to come back, it's like, he'd rather be burnt out than bored. Again, this is the kind of people on the team, and someone else that, but if I spent a whole week off, my brain would, so he'll take a couple of days off to be with his family for the work-life balance, but he realizes that after that, he just gets too antsy. He's got to get back into the fight the whole time.
Right. Exactly.
And again, just kind of finish the whole thing off here is that, one of the things that Elon made as a stated goal is that, he promised there would be millions of them. Exactly. And again, it's like the chapter ends right here. It's like, oh, there was more to AI Day 2 than this. Oh, yeah. Come on, Walter, give us more. But the thing is, if he gives us more, it's going to be this tone. Already you can sort of see what it is like over there. But it's very readable, and I definitely recommend it.
It is. It's I think maybe we could stop screen sharing for the last little bit here, but yeah. So I think, the book is a mass market book. It's a lot of the stuff after reading asks, oh, look at that AG1 ad. Drink your AG1. Good stuff. There you go.
I forgot this morning, so I'm dying of thirst.
You got to do it. And while you're doing it, make sure you drink it out of your Cybertruck mug while you're, just go ahead and pitch everything. But anyway, so certainly Walter Isaacson's book retreads a lot of the territory that we saw in Ashley Vance's book, because of course, up to what was it, 2015, something like that, when he did his book. So a lot of that's repetition, and it's a mass market book, so it doesn't get into some of the details that we have, but it's still incredibly valuable. There's still a lot of amazing nuggets about it. But as you say, I'm the kind of person who's like, I want the data dump of his notes. I don't even care about the book. Just give me a dump of all of the notes that you took during all these meetings and all the shadowing him, because I'll go through those, and those would have way more interesting information.
Man, in some ways, I wish they had hired Tracy Kidder to sit there like a fly on the wall, because he wrote the Soul of the New Machine back in the 80s, where he was embedded for a year in the team that was designing the Data General computer that was supposed to be a rival to the DEC. And it was just fascinating. I mean, because it was like everything that went into it, the engineers that were kind of brought in and run through the meat grinder, because the way you do a project like that is you don't take senior engineers because they're too wise to what you're doing. Right. And what you do is you hire a bunch of new guys out of college that have no idea what's going on and think that 80-hour weeks is the norm and the way it's supposed to be. And you just crush their souls, get it, extract everything out of them for 2 years, and then they quit. And you're like, so what? we got what we wanted out of them.
Exactly.
And it was like, yikes. And so basically the soul of the new machine was basically stealing the souls of everyone else and putting it into this other computer, and how wild some of these people were, and what they did, what they did, they considered to be fun was like these really risky, dangerous things. So you begin to wonder, man, what's their job like? It's so stressy that this is what they do to unwind. It would be nice to sort of see someone write that, and who knows, maybe there is a second book out there. And oh, we still have a few minutes here before we have to jump into the next. So if you notice, I mean, in the next live stream, we'll probably still have the same t-shirts on.
Oh, I'll definitely have the same shirt on. I don't have time to get changed.
Well, there's no problem. I mean, unfortunately, you can't smell over YouTube, so that's fine. We don't have to do a change.
I've got my Tesla shirt on. This was from Shareholder Day. I should have worn the AI Day one, but I think, everyone was, there were so many people that were bored with AI Day that I'm really worried that AI Day 3, which I've heard is going to be early 2024 now, unfortunately.
Oh, that's what you've heard?
That's what I heard. But anyway, I've heard, what I'm worried about is that they're going to decide to slick it up and make it like, fancy for the shareholders. And I really, really hope they don't do that.
Oh, yeah. Well,
that would be a shame.
I was interviewed by Herbert last night, and it's going to come out on Saturday. But this is coming out after, so it doesn't matter.
Oh,
or maybe, but
wait. Oh, is that a new revelation that the 2020?
No. We were just kind of talking about when we think AI Day 2 would be. And Herbert brought up a really good point, because I was saying, it's going to be, sometime mid-November, because that's when you're going to have the first Teslabot with what are probably the actuators that are actually coming off the line and everything else before they get ready to scale. But then he also pointed out, it's like, well, it's not just about Optimus, it's also about Dojo. So it might be that Dojo has to be at some point. It's not going to be, oh, look at the Dojo chip again, and someday, it's going to be, look at this data. Here's the real hexapod that we have out here. I mean, just they're going to do like an impressive demo of something on there on what it really can do. So you got to have that one. And the third one is going to be probably V12. All three of those have to be ready for prime time. And if one of them is not, it's delayed. And so that's why I kind of agree. It's probably going to be January, because early November is usually the end of anything that you can do. Early November, because then Thanksgiving, I don't want to get them out there. Everyone's getting ready for Christmas and get New Year's. So December is kind of out for something like, Cybertruck was December, so that was my thesis.
But the odds are,
remember, Cybertruck was something different. That was a consumer event. This is, again, a recruiting event. So it might be something a little bit different. Recruiting event. Let's recruit all these grad students that are in the middle of finals in December. So it's not going to happen in December.
So anyway, I'm disappointed, because I was just thinking that like a year ago, I was getting really excited about going to AI Day 2, because it was just a couple weeks away, but we will wait. We'll be patient.
And which you notice that they're doing it. It was AI Day 2021 and 2022, which means, well, where's the 23? That means we have to have it 23. So now they've been calling it 1 and 2. So 3 can be whenever they want.
So there we go. All right. Thank you so much, Scott. That was a lot of stuff. Again, we always make hay out of relatively few pages or pictures or anything like that. So nice work with that.
Those YouTube talking heads.
There we go. We're going to take a 2-minute break. We're going to go live stream with Hans, and we'll, so go watch that. Although by the time you see that, I'll put a link to it, because it'll be rebroadcast by then. But anyway,
and thinking, I guess the only thing to say about the book with all these vignettes that basically all the chapters are is every time you read it, because it comes up short, all I could think of is like, need more cowbell.
Exactly.
More cowbell.
Always. So Walter, give us geeks just the notes. We don't even need them formatted. Just give it to us.
Yes, absolutely.
Cool. All right. Thank you so much, Scott. Everybody do the like and subscribe. Follow Scott on Twitter or X. You are a rising star there, clearly. So, all right.
Gotta be careful what you post.
Yeah, exactly. Right. Let that sink in. All right. Everybody have a lovely day. We'll see you in the next one. Bye-bye.
Okay. Yeah. Bye-bye.